Welcome back. Today we're going to be looking into the general form of a straight line. The general form is, again, another way for you to write an equation of a line. So before we look into that formula of a general form, let's just have a little recap. At this point on, you should know three forms to write an equation of a straight line. The first one is y equals mx plus c. This here is your gradient intercept form. Okay. Your second one is the one that we looked into in the last video, which is y equals y1. Oh, y minus y1 equals mx minus x1. Okay, this is what we call the point gradient form. Okay, and the lucky last one is the one that we're looking on today, which is the general form. And the equation for that is capital A x plus capital by plus capital C equals to 0. That is my equation for my general form. Now, with the general form, there are two conditions that needs to be met. Okay. First condition is that capital A, B, and C are all integers. When I say all integers, it means that it must be a whole number. Okay, it can be positive, negative, or 0. Cannot be a fraction. Okay, that's the most important part. A, B, and C cannot be a fraction. That's the first condition. The second condition is the following. Capital A must always be positive. It cannot be a negative number. Okay, must be either greater than or equal to 0. Okay, so it can be 0, but it can never be lower than 0. So I'm just going to make it as A must be positive or 0. Two conditions, okay, needs to be met for this one. It's very important that you ensure that those two conditions are met. So let's go to our example. Write an equation in general form. To make our lives easier, to not just go back and forth, let's write down the general form, the equation for this one here. Capital AX plus BY plus C equal to 0. Okay, that's my general form. That's what it should look like. Again, I'm just going to preface before going to an example that B and C can be positive, negative, or 0. It doesn't really matter as long as A is positive or 0. Okay, cannot be negative. So question number A, y equals 3x minus 1. So this is how we're going to solve it. We're going to do it in steps. So if y equals 3x minus 1 is my equation, and I need to change it into my general form, I'm first going to see if I can meet the two conditions. I'm going to first look at this condition here, that A must be positive or 0. So I'm going to double check. Okay, my A is basically the number next to the x. Okay, number next to the x in y equals 3x minus 1 is 3x. Is 3x positive? Yes, it is. If it is positive, leave it there. Do not move it. Okay? Now, if your AX is positive, leave it. What we're going to do now is we're going to move any other, either the y or the constant, right, the number, to the other side. What I'm going to do now is I'm going to subtract y to move it to the other side. Y minus y equals to 0. Okay, so that cancels out. It'll be 0 equal to 3x minus y minus 1. See how now it looks like my general form, right? You can write it as 3x minus 1 minus y. It's fine, but I would like to have the y in the middle just so that I can see it's similar to my general form. And that will be my answer, okay? You can write it just to make sure it looks similar to my general form. You can write it down like that, okay? That's question number A, super easy. Question number B, okay. I'm going to check if my A is positive. Okay, in this question, it says y equals negative 2 over 3x plus 4. Where's my ax? My ax is this one right here, this term, negative 2 over 3x. Is that positive? No, it's negative. So what I'm going to do is I'm going to now try to move it to the other side to make it positive. To do that, I am going to add the whole term, okay? I'm going to add 2 over 3x on one side, and I'm going to do it also on the other side, the whole term, okay? This will cancel out. What I'm left with now is 2 over 3x plus y. This y is a positive, okay? Equal to positive 4. I need to now move this 4 to the other side to make sure it's in my general form. I'm going to minus that on both sides. What I'm left with right now is 2 over 3x plus y minus 4 equal to 0. Okay, so one of my conditions has been met. This here, a is already positive. 2 over 3 is positive. But my second condition is that all my integers, a, b, and c, needs to be an integer. Cannot be a fraction. What do I see in my a? I see a fraction. So what I'm going to do now is I'm going to get rid of this 3, this denominator of 3. 2 over 3, that over sign here, okay, it means divide. What's the opposite of divide? Well, the opposite of divide is multiplication. So I'm going to multiply 3 on each term in this equation. So I'm going to multiply 3 where the y is, multiply 3 where the negative 4, as well as multiply 3 on the other side. This will cancel out because they're both the opposite. What I'm left with now is 2x plus what's y times 3? Y times 3 equals to 3y. Minus 2, 4 times 3, which is 12, equals to 0. That is my general form. If you have another fraction in your y, so in here, let's say for example, if I had another fraction, I want you to first focus on making the a an integer, and then try and see if the b is still a fraction, then do the exact same that you did to a, right? You do it to each fraction. You multiply that denominator again on each fraction, on each term. Hopefully that makes sense, and I'll see you in the next video. Bye.